Hi, this is Mr. Max. So what I'm doing today is matrices. So I'm going to do a three-part video series on matrices. So this is part one of three. All right, so what we have here is we have a matrix consisting of two rows and three columns. The rows is what you have when you go like horizontally. So that's row one, and row 2 is the one at the bottom. So these numbers inside here are referred to as elements. All right, so that's the column 1, that's column 2, and column 3. So whenever you refer to a matrix, you always have to start with the row followed by the number of columns. So this is typically a 2 by 3 matrix, or you can say a 2 times 3 matrix. Okay, always you must write the row number and then the column number. Also, again, as I said, this is a way of writing a lot of information, so I'm not going to go into the practical side. I'm just focusing, and I hope you have done the notes and you understand where matrices are used in real life situations. Now remember what I said, the numbers inside are referred to as the elements, and then always we represent matrices by using capital letters. It's either is going to be printed in bold or underlined. So I'm going directly into a small exercise where you ask here to state the order or the size of each of the following matrices. Remember, you start with the row, so there are two rows and one column, so this is a 2 by 1 matrix. The next one here, it's two rows and two columns, so this is a square matrix, or it's a 2 by 2 matrix. Very important that you understand what is a 2 by 2 matrix. This one here, you have got two rows and four columns, so this is a 2 by 4 matrix. This one here, one row, two columns, so it's a 1 by 2 or 1 times 2 if you prefer to say it like that. This one is one row and 5 columns, so that's a 1 by 5 matrix. Can you see that it's also denoted or represented by capital letters, and here in this case they are bolded. So this is matrix P consisting of 4 rows and 3 columns, so this is a 4 by 3 matrix. This one here, careful, these are decimal numbers, so it's a 4 row and 1 column, so it's a 4 by 1 matrix. This one here is just a 1 by 1 matrix. Okay, 1 row, 1 column. 1 by 1, 2 by 2 are also referred to as square matrices. The last one that I have here, you have got 2 rows and 1 column. So remember, that's just 2018, and the one here is 4132. So it's a 2 by 1 matrix. Right, so there are some special matrices, all right? The row matrices are matrices that just consist of a row, one row, different columns, right? This, for example, is a 1 by 2 matrix, a 1 by 3 matrix, and a 1 by 4 matrix. So the row matrix. Then obviously the column matrix, just columns, all right? One column consisting only of one column. Then the square matrix, okay? So you have got 2 rows, 2 columns, or 3 rows, 3 columns. Can you see that? Or 1 by 1, 1 row, 1 column. These are all known as square matrices. The zero matrix, or also referred to as the null matrix. Now, all the elements is just 0. So this is an example of a zero matrix. And then the last one here, the equal matrices. Now, very much important for you to understand that equal matrices have got exactly identical elements. All right, identical elements, same order, so it must be a 1. This one is a 1 by 2 or 1 by 2 matrix. This is a 2 by 2 and a 2 by 3 matrix. Corresponding elements are equal. This -8 corresponds with that -8. This 2 corresponds with that 2. Not the other way around, okay? Then it's not equal. So when you have every element in a matrix is equal to 0, we always represent it by a little o. refer to as a zero matrix. So I'm bringing in here that concept of your equal matrices, where we say one element is exactly equal to its corresponding element. So what we do here is you're supposed then to calculate the value of x and the value of y. Now x is very easy. X should be -3 because these components or these elements, they should be equal. And the next one you say 6y is equal to -15, and you solve for y. In this case, y is 2.5. Now, this one says find the value of each of the unknowns. So you have 2p equals to 14, 2k equals to 18, 6h equals to 36. So I'm just going to bring them. 2p equals to 14. You solve for p is equal to 7. 2k is equal to 18. K is equal to 9. And then 6h is equal to 36. Or first of all, 3q is equal to 15 there. Therefore, q is equal to 5, and 6h is equal to 36. Divide throughout by 6, h is equal to 6. Another one here, so this is just a half. A equals to 3, a plus 4 equals to h. So once you determine what a is in the first instance, you substitute to get h. And 3b equals to 27, and k minus 9 equals to 5. So I'm going to do the first one. A half of a equals to 3, multiplied by 2, a is equal to 6. Now that we know what the value of a is, you substitute it here. A plus 4 is equal to h. So that's 6 plus 4, therefore h is equal to 10. The next one here, k minus 9 equals to 5, corresponding elements, remember, and that gives you k to equal to 14. And 3b equals to 27, therefore b is equal to 9. Right, so we have another one here. We say find the value of each of the following. So you can pause the video and then you can try to attempt to solve them on your own. So if everything here is equal to 0, you can simply just say 2x minus 5 is equal to 0. And then you solve by adding 5 to both sides, and x therefore is equal to 2.5. The same you do with y minus 4 is also equal to 0. Okay, so when a matrix is equal to 0, it means that each element in the matrices or in the matrix is equal to 0. So y equals to 4, and h plus 3 is equal to 0, giving us h2 equal to -3. And 5k is equal to 0, therefore k should equal to 0. Right, so the third one that I have here, also the same issue. So you have got sine theta equals to 0.5. So sine theta, or theta, is the sine ratio is positive in the first and in the second quadrant. But you must remember here, if you have done your work on trig, that they want theta to be an angle between 0 and 180 degrees. So in the only quadrants where the sine ratio is positive, all the ratios are positive in the first quadrant. And on the second quadrant, the sine ratio is also positive. And these are the two angles that we are going to look for because it is adhering to our domain here. All right. So we know that whatever theta is, so we say sine theta is equal to 0.5. Make sure your calculator is in degree mode. And you have to press the second function or shift in order to find the inverse of this ratio. And that gives you the angle of 30 degrees. So this is a reference angle, but it is also an angle that we are looking for. So our theta will be 30 degrees, and that will be in the first quadrant, and you can see it's an acute angle. But in the second quadrant, it has to be an obtuse angle. So we're going to take our 30 degrees, subtract it from 180. So that means we have two solutions where the sine ratio is a half. That means theta is equal to 30 degrees or theta is equal to 150 degrees. Because if you press the sine of 30 degrees on your calculator, you're going to get 0.5 as the ratio. Also, if you press sine of 150 degrees, you're going to get 0.5. Okay? Right. And then you have another one here. You have got find the value of y. So again, you take 3y is equal to y plus 4. And then you just solve for y. Subtract throughout by y. 2y is equal to 4. Therefore, y is equal to 2. Right, then there are some operations that we carry out with matrices. We obviously add or subtract. Now you see I put or subtracting in brackets because what I do sometimes, and you will see later on, I change my subtraction to a plus and then I work with the minuses inside. Okay, it's always easy to add, but what you do is you just add corresponding elements in each matrix. So it's very important that the matrices must be of the same order or the same size. This is a 2 by 3, a 2 by 3, and a 2 by 3. Okay, if it's the other way around, say suppose it's a 2 by 2 by 3 versus a 1 by 3, it will not work. Then it will not be defined. Okay, there's some differences won't exist. But in this case, matrix A, matrix B, and matrix C are of the same order. Right, so what I want us to do here is we're supposed to add A plus B plus C, matrix A plus matrix B plus matrix C. So what I did here is, you see I've color coded them so that it's a little bit easy for you to follow. Right, so you have got 4 plus 3 plus 0, and then obviously you take your 3 plus 1 plus negative 2, and so on. And then you clean this up and you should get that the sum of matrix A plus matrix B plus matrix C is equal to 7, 2, 8, negative 3, 3, negative 11. Make sure that you don't make mistakes when you are adding and subtracting negative numbers. So I suggest that perhaps you use a calculator in order for you not to make a mistake if you are struggling with directed numbers. Right, the second one here, I have got evaluate the following. So this is going to be 7, 1, 3, 4 plus that should give plus 0. And the second one you have is you have got y, x, 2y minus 3. Basically this matrix minus that matrix. And here you have find the values of A and the values of B, where the difference of these two matrices gives you that answer. Right, so in the first instance, what I did is I said 7 plus negative 3 plus 0. So I put 0 there, but you can obviously leave it out. Again, 1 plus 2 plus 0. Then I have 3 plus 5 plus 0 and 4 plus 7 plus 0. You should get 4, 3, 8, 11. Again, as I said, pause the video and try to solve these questions yourself. So here you just have letters or variables. It's the same concept. So very careful. Y minus negative y becomes 2y. Okay, x minus 2x becomes minus x, and 2y minus 2y, obviously that gives you 0, and 3x minus 5x, that gives you minus 2x. It's not necessary maybe for you to show this step here, but I prefer to do it so that I don't get confused with my final answers. Right, so what I will do here on the left, I'm going to try to sort of simplify that part here. 5a minus 9, and negative 1 minus 6, and 6 minus 4, and 2 minus negative 7, 3b minus b, and 3 minus 5. Okay, so if I clean this up here, I'm going to get the top here, negative 1 minus 6. Obviously, that's going to give me negative 7. And here I've got 5a minus 9, and so on. So what I have now, I have got a matrix here is equal to the matrix there. So you take each corresponding element, 5a minus 9, let it equal to 16. And then you can solve for a. Add 9, that gives you 25. Divide by 5, that gives you a equals to 5. Then this 2b should equal to nothing but negative 28 here. And when you divide throughout by 2, you get that the value of b is equal to negative 14. Right, so I have got a few questions here. Again, feel free to pause the video and then attempt to solve the following 3 questions. So here the first one is A plus matrix A plus this matrix here should give you that value. So the best thing is to sort of make that A the subject of the formula, if you understand what I'm saying. So get that matrix, the 4, 3, 2, negative 3, that matrix on the other side, so you're going to subtract it. And then you subtract each component from each other, 8 minus 4, 6 minus 3, negative 2 minus 2, 5 minus negative 3, And that should be your answer there. And the same applies here. You get that A on its own. So this 3, negative 4, 6, this row vector here, this matrix here, you will be subtracting it here with the other one. And obviously, you should end up with negative 3, 0, 3. So the same applies. A little bit careful with this one. I suggest you move the A to the right, and then you get this matrix 6P minus Q to the left. And once you do that, this becomes a negative and this A becomes positive. So now you can subtract the elements from each other. Careful when you subtract negative 3Q minus Q, you're going to get a positive 4Q there. That should be the answer that you arrive at. Right, so multiplying a matrix by a scalar, so basically it's just a number or a constant, all right, that we multiply every element in the matrix with. And this is scalar multiplication. So we are not dividing matrices, but rather we're multiplying by a fraction. So for example, if we say matrix A to be divided by 2, we just say a half times matrix A. And that half will then multiply with each element in that particular matrix. All right, so I've got 2 here that you can try, and there are further ones coming. So again, feel free to pause the video and attempt this on your own. So remember that 2 multiplies with the 4, 2 multiplies with the 7, and so on. The 3 multiply with every element there, and then you add them. Right, so once I do A, I end up with my final answer to be 8, 20, negative 5, and 13. So I showed step by step. You see, I multiply each element here by 2, and in the second matrix, I multiply each element by 3. And then I clean that up and I add them to get to that final answer. The same applies with what I do here. But look at what I do in the second instance. I'm changing this negative 7 to a positive here, and then I have inside a minus 7. It's always easier to add. All right, so I have got 4 times negative 7 and 3 times negative 7. So this is going to become a positive in the moment I do that. Right, so when I clean this up, I should get eventually to a final answer of negative 53, negative 31. Right, so I have got question 2 here. They say let matrix A be that and matrix B be that. So first they want you to say 3 multiplied by A, matrix A plus B. Or you take matrix A times the constant there plus matrix B times the constant, and what can you deduce from this particular concept? You should be aware of how I use my brackets here. So I'm first finding the sum, I'm adding the matrices. And when I add those matrices, I get 1, 5. And then I multiply each element there by 3, eventually getting 3, 15. Again, when I do B, I'm going to multiply the 3 here with 5 and 3. And here I'm going to multiply negative 4 and the 2 also by 3. And once I do that, I end up with 59 plus negative 12, 6. And I'm just going to simply add the elements, the corresponding elements together, all right? And I eventually end up with the same answer, the distributive property of addition. So what you are seeing here is there is basically a very good relationship that whatever that constant, that scalar is going to equal to sort of like distributing it over there. Right, so we have a second question here. And I will probably also advise you maybe here to pause the video and to attempt to solve this on your own. Right, so what I did is I then obviously I brought in what is matrix A, matrix B, and matrix C, and then can you see that here in this first instance I multiply each element by that constant there, or that scalar. Right, the same applies here with negative 4, and I change this to a positive if I multiply with a negative 4 inside. And here obviously you can just have your positive there and times 3 for each of those elements. Now if you do the first part, rather leave your answers like this as a fraction, because you are going to multiply again by that quantity, that 6 there, that scalar. Eventually, you should get to solve the, the matrix. Like in this case, negative 2 over 3 times 6. Well, 3 goes into 6, it's very easy, and 3 goes into 6 in this case, so you should have negative 4, 6, 16, and 10. Now, you can now go ahead and add the corresponding quantities or elements. Now, you see I also color-coded them to make it a little bit easier for you to follow. Okay, so once you clean that up, you should arrive at the final answer, which is negative 22, 1, negative 15, 27. Right, don't forget to subscribe to my channel and also to click the notification bell so that you can notify every time that I'm going to post videos. So tomorrow I'm going to put part 2 and part 3 of our work on matrices. So make sure that you follow and also prepare for the examination. So part 3 or the fourth part will be questions based on examination exercises. So it essentially is a 4-part video. Okay? So make sure, again, as I said, that you go through the questions, try to do them yourselves, and tomorrow we're going to look at multiplying a matrix by a matrix and finding the determinant of a matrix. And also we're going to look at finding the solving them by simultaneous equation. Well, the simultaneous equation, we will do those ones a little bit later in the fourth part video. Okay, so the matrices, very important that you understand. We take them step by step, and if you didn't get that, please try to go back, revisit the questions and attempt to solve them.